So the next piece of the puzzle, or really the first of this entire unit, is something called expanding. And I mentioned in the 5.0 lesson, an instruction that you're going to see a lot is the instruction expand and simplify. We see it right here. And it basically means you're given an expression, expand it out to all of its terms, and then collect and simplify it as best we actually can. Now we're going to use a number of strategies to do that, the first of which is an idea of multiplication. So when we're multiplying polynomials, so when we have a polynomial multiplied by a polynomial, in this case these one has two terms times two terms, right? When multiplying polynomials, what we're going to do is we're going to multiply each term in one bracket by each term in the second bracket. So one at a time. So when multiplying binomials, we see it right here. These are binomials. Those are two terms. When multiplying binomials, we're going to use the acronym FOIL, which is used to explain the order of the multiplication. FOIL stands for first, outside, inside, and last. And then after we're done multiplying each term, we're going to collect all of our terms and we're going to combine them. We're going to combine any like terms we can. Now, what do I mean by the FOIL part here? So imagine I have a binomial that looks like this, A plus B. And over here, I have another binomial. Let's say it's C plus D. Doesn't really matter what the terms are. We're just looking at order here. So FOIL says multiply to the first term and then multiply to the outside term. And then internally, we're going to say now multiply the inside term and finally the last term. This will multiply each term of the first binomial by each term in the last binomial. So let's try it out. So over here in number 1a, we're going to multiply x times 3x. So that's going to give us 3x squared. X times x is x squared. Now we have x times negative 5. So that's minus 5x. So we've done the first part. We've done the top here. Now we do the bottom. We're going to take the second term, which is a negative 4. That negative sign comes with the 4. Negative 4 times 3x, that's negative 12x. And now we have negative 4 times negative 5. That's going to be plus 20. So we've expanded. Now we need to simplify. That means combine all of our like terms. I only have one x squared, so we're going to leave that one alone. It's the highest order exponent, so we're going to leave it over here, all on the left. And now what x? Oh, we have two x's. We have minus 5x and minus 12x. This is going to be minus 17x. Minus 17x, and only one constant, plus 20. And that's it. That's the whole process. So let's rinse and repeat and try it a few times. You can pause the video and try and go through it on your own if you'd like. But if you want to follow along, let's do that. So we have 2a times 2a. So 2 times 2, that's 4. A times a, that's a squared. Now we have 2a times 1. So that's just 2a. Now we have negative 1 times 2a. Well, that's negative 2a. And now we have negative 1 times 1. That's going to be negative 1. So we combine our terms. So we only have one square term. So this is going to be 4a squared plus 2 minus 2. Oh, the a's actually cancel out. They're gone. And then we just have our minus 1. Interesting how that worked out. So now let's go on to the next one. We have 5m minus 6 squared. Well, what does square mean? It means multiply it by itself. So let's write that out. So that means we have 5m minus 6 multiplied by 5m minus 6. The whole term is squared. So now we apply FOIL. 5m times 5m, that's 25m squared. Now we have 5m times negative 6. That's going to be minus 30m. Now we have negative 6 times 5m. That's going to be minus 30m again. And then finally, we have negative 6 times negative 6. That's plus 36. We collect our like terms. There's only one m squared, so we leave that alone. And then we have minus 30m. That's minus 60m. And we only have our one constant, which is going to be plus 36. All right. Same question right to the right here. Again, we have a square, so we're going to expand that out. So we have 4y plus 7 times 4y plus 7. And we FOIL. 4y times 4y, that's 16y squared. 4y times 7, that's plus 28y. And now we have 7 times 4y, that's also plus 28y. I'm sure a few of you have noticed some patterns going on. We have 7 times 7, that's 49. And now we can collect our like terms. The only like terms we have are the two y's over here. So 16y squared gets left alone. Now we have 28 plus 28, that's 56. Y, and then plus 49. We've simplified and we've expanded. Or I guess we expanded first, then we simplified. Okay. So this one down here, 3 times 2x plus 5 times 9x plus 1. So what do we do first? Should I put that 3 through there? I can. I absolutely can. But then that's going to complicate and add an extra layer to my next step because my numbers are going to be bigger and not as easy to work with. So in this case, I'm actually going to leave the 3 alone. Okay? And now I'm going to still do the FOIL process with the two bracket terms. So in that case, I have 3, and then all on its own inside a set of brackets, we're going to have 2x times 9x. That's 18x squared. Okay. And now we have 2x times 1, so that's just 2x. 5 times 9x, that's 45x. And then we have 5 times 1, that's just 5. We can collect our like terms. So we're going to leave the 3 alone still. We're going to simplify things. There's only 1x squared, so it's still 18x squared. Now we have 2x plus 45x, that's plus 47x. And then we have plus 5. Now, we can't do anything else internally, so now we'll multiply the 3 through every single term. So 3 times 18, that's 54. Now we have 3 times 47, that's 141x. And then 3 times 15 is 15. Or sorry, 3 times 5 is 15. Got ahead of my own brain there. Okay. Over on the right-hand side, we have a very similar idea. We have 2 terms. I can't do the FOIL on this right now because this whole term is squared. So the math doesn't actually work like that. We have to expand this square first. So we have 3n minus 1 multiplied by 2n plus 3 times 2n plus 3. So let's leave the 3n minus 1 alone. I could start with that if I wanted to. The math would still work. It's just not as pretty. So now we have 2x times 2x. That's 4x squared. And now we have 2x times 3. That's going to be 6x. Now 3 times 2x. That's also going to be 6x. Now we have 3 times 3, which is 9. We're going to collect our like terms. So we have 3n minus 1 still, all on its own. And then we have 4x squared. And we have 6x plus 6x. That's going to give us 12x plus 9. Okay. Now you're like, wait, you have a binomial multiplied by a trinomial. Does it still work? It certainly does. It just means that we would multiply each term by all 3 terms. If there were a third term, I would go here, and then I'd go here again. It's still the same idea, doesn't change. If we read the first statement, when multiplying polynomials, multiply each term in one bracket by each term in the other bracket. Okay, let's do the work. 3n times 4x squared. So we end up with, wait, how did I get x's? Those should be n's. I don't know how that happened. So let's go back and fix these because that definitely changes the problem. Ugh, I think I'm destroying everything here. We're going to have to do a little writing here. Oh my goodness, this is the worst eraser tool ever. Okay, let's try this again. We'll see if we can clean this up over here. So we have 3n minus 1, and then we had 2n plus 3 multiplied by 2n plus 3. And then down here, we ended up with 4n squared plus 6n plus 6n. Okay. And then we end up with 4n squared plus 12n plus 9. All right, now we're back to where we actually should be. This makes much more sense now. So we have 3n times 4n squared. So that's going to give us 12n cubed, because we add the exponents from the addition rule in the previous lesson. 3n times 12n, that's going to give us plus 36n squared. And now 3n times 9, that's just going to give us 27n. All right, now we go to the second term. Negative 1 times 4n squared, so that's minus 4n squared. Negative 1 times 12, that's going to be minus 12n. And then we have negative 1 times 9, that's going to be minus 9. So we had to collect all of our like terms. I only have 1n cubed, so that's going to be left alone, 12n cubed. How about n squares? I got two of those. I have 36n squared and minus 4. So this is going to give me plus 32n squared. And then we have 27n. Do we have any other n's? Yes, I have a minus 12 there. So that's going to be the same thing as 15n. And then finally, there's only one constant, which is the minus 9. That's it. So those are all the examples of expanding and simplifying using our FOIL process. So there's some shortcuts we can take. Everybody loves shortcuts. If you are, as you gain experience and as you practice, as I said before, this is probably one of the most important units to practice and practice and practice. Even when we're done the unit, you should still put some time in and add more practice in, because the more time you put into this, the easier it is going to be to recognize the shortcuts to save yourself a lot of time. So let's take a look at some of these shortcuts you're going to learn. So there are some special cases when expanding and simplifying. Let me go up a little bit so we can see all the work we just did. There's some special cases that when we're expanding and simplifying. So here are some following shortcuts. Whenever you see a plus b all squared, that can be simplified into just a squared plus 2ab plus b squared. So look around. Do you see anywhere we have some term plus another term and then the whole thing is squared? Definitely not the first one, not the second one, not the third one, because that's a minus. The fourth one. Yes, there it is. 4y plus 7 all squared. That's the same thing as here. Well, let's see if that actually worked out. This is saying I can take my first term and square it. So my first term was 4y. If I square that, 4 squared is 16. Y squared is y squared. Okay, so that worked. Great. And then the next one was 2 times a times b. So 2 times a, so 2 times 4y would be 8y times b, which is 7. That'd be 8y times 7 would be 56y. Okay, that second term checks out as well. And finally, the last term is just b squared. Well, in this case, b is 7, so 7 squared is 49. Yeah, this all checks. So this is the equivalent to D here. So a plus b all squared, we can just say that is going to be a squared plus 2ab plus b squared. So we can basically skip all the steps and go right down to that end step. Great. Similarly speaking, we see another one. If we have a minus b all squared, it's the same thing, except the middle term is going to be a negative value. We see that right here in, no, not in C, I lied. Yeah, it is in C actually. Because when we see the minus sign right here, and the whole thing is squared out. So we have a squared, which is 25m squared, minus 2ab. So a times b is 30m times, negative 30m times 2. So that'd be negative 60m. Perfect. And then b squared is negative 6 times negative 6, which gives us 36. So this is the same as C. Now this last one, eventually we're going to give this a special name in a future lesson, but for now we're going to not give it that name. But when you see a plus b times a minus b, what you end up with is the square of a minus the square of b. We actually see this right up here in example B. A minus b times a plus b. It's the same thing. They're interchangeable. So in this case, we end up with our a squared, which is 4a squared, right? A squared, 4a squared. 2a squared is 4a squared, minus b squared. Well, there's our b, which is negative 1, so minus b squared is negative 1. Okay, are we all done? Yeah, we're done this part. Let's move on. Let's move on. So we're going to apply this a little bit further. We're going to try and use our shortcuts. Let's keep our shortcuts on the page so we can see them. Alrighty. So looking over here, use the shortcuts to expand and simplify. So we're not going to do all the steps. We're just going to solve the problem with our shortcuts. So which of our shortcuts do we have here? We have a minus b times a plus b. Oh, that's the last one right there. So we're going to square the first term. So that's 25x squared. And then it says we should subtract the second term squared. What is the second term? It is 2. So subtract 2 squared, which is 4. There we go. That was much easier. Nice. Over on the next one, same idea. We still have a plus b times a minus b. So in this case, we're going to have a squared, which is 9m squared. And we're going to subtract from that b squared, 4, so that's 16 all on its own. 9m squared minus 16. All right, a plus b all squared. There it is, right at the first one. So we take the first term and square it. So that's 25a squared. Now the second term is 2 times a times b. So do a times b first. So this would be 5a times 4. That's 20a. Now multiply it by 2. So we have 40a. And then finally, our last term is just b squared. Yeah. So in this case, 4 squared is 16. So we have plus 16. Awesome. And now the last one here. So we have a minus b all squared. So that's the middle one. So we have a squared, which is 4, minus b squared. So that's 7 squared is 49, b squared. Now we can't leave it like this because we always want our highest order term on the left-hand side. So we're actually going to rewrite it as negative 49 b squared plus 4. Okay? So now we've done the expansion and the simplification using our shortcuts. Let's take it one step further and let's apply it to some geometry. Find an expression for the area of the following shapes. Well, what kind of shape are we looking at here? We can see in this shape, both sides have the exact same dimensions, the exact same values, 4x plus 1. So that tells me this is a square. What's the formula for the area of a square? Area for a square is area is equal to the side length squared. Okay. So let's write that out. So area is equal to the side length, which is 4x plus 1. All squared. Now we can apply our shortcuts, which is a squared, 16x squared. Since this is a plus, we add plus 2ab. So multiply these together. 4x times 1, that's 4x, times 2. So that's going to be 8x. Plus b squared. 1 squared is just 1. And that's the answer. So this is our expression for the area of this square. Similarly speaking over here, this time we have a rectangle. And we know the area of a rectangle is equal to the length times the width. Well, if this is our length and this is our width, that means that our area is equal to 2x plus 5 multiplied by 2x minus 5. So now we're looking at a plus b times a minus b. So this just gives us a squared minus b squared. Yeah, a squared minus b squared. I had to check my notes just to verify. I didn't want to go wrong here. So a squared, that's 2x squared, so that's 4x squared. And then minus b squared. So minus 5 squared is minus 25. And there's our equation for the area of a rectangle. This rectangle specifically. Find the volume. Find the volume expression. Well, volume, what is the volume of a rectangular prism? Volume is equal to length times width times height. So if this is the length, this is the width, and this is the height, here's our formula. Volume is equal to the length, which is 2x plus 3, multiplied by our width, which is x plus 2, multiplied by our height, which is 3x minus 4. Now we got to look at that and say, well, are there any shortcuts? No, not really. We can't manipulate anything. They are what they are. So in this case, we just have to do the work. So let's start by, I like to work on the right-hand side first. So we're going to leave the 2x plus 3 all alone. And then on the right-hand side, we're going to apply FOIL. So we have x times 3x, that's 3x squared. And we have x times negative 4, so that's minus 4x. 2x times 3x, that's going to be plus 6x. And then 2 times negative 4 is going to be minus 8. Collect our like terms. 2x plus 3 is still left alone over here. And then inside, we have 3x squared all on its lonesome. Minus 4x plus 6x, that's plus 2x. Minus 8. Now we can apply the FOIL process again, but this time with a binomial and a trinomial. Let's do it again. 2x times 3x squared, that's going to give us 6x cubed. This makes sense because we're talking about a three-dimensional shape, and volumes are always a cubic value. So 2x times 3x squared, that's going to be 6x cubed. And then we're going to keep going. So 2x times 2x, that's going to be 4x squared. And then we have 2x times negative 8, that's going to be minus 16x. I think my computer's starting to go on me here. I hope it doesn't crash on me and we ruin our video. We'll see. 3 times 3x squared, that's 9x squared. 3 times 2x, that's going to be 6x. And then 3 times negative 8 is minus 24. Let's collect everything. We only have one cubic. So 6x cubed all on your own. 4x squared plus 9x squared. That's going to give us plus 13x squared. So we have minus 16x plus 6x. That should give us minus 10x. And then finally, the only constant we have is the minus 24. Now, what I would say is that for each one of these, because we're talking about a measurement, for each one of these, I'd like you to end them off with a unit. If you have the units in the question, centimeters, meters, whatever, you should have that written down. We don't have that, so we're just going to write units, the general term. In this case, because it's an area, they'd be squared. Over here, it'd be units squared, and down here, it'd be units cubed because it's a volume. And that's it for our expansion, our polynomial expansion. So that is taking stuff from a smaller value and expanding it out to all of its terms. Next lesson, we're actually going to go the opposite direction. We're going to have something fully expanded, and then we're going to try and factor it down into a smaller, more cleaner version of everything. That's it for now.